Okay, hello. And so I just wanted to show you how like an underlying project of the new Overmind project works. It's called proxy state tree, and it's kind of like MobX, though MobX is more about observing values, while this project is about observing a state tree. And it's of course implemented with like latest proxy implementation in JavaScript, and it's pretty awesome how it works. So I wanted to show it off. So let's see. Let's just import proxy state tree from proxy state tree, and we are just going to play around with it. And hopefully, I haven't prepared anything, but hopefully I can get my point across here. Okay, so the first thing we need, and Overmind has a single instance of this, and that is the proxy state tree itself. New proxy state tree. And what we do is we pass it the state, the complete state. So let's pass it foo bar. Okay. So what we can do now is, well, I guess we can console log proxy state tree.state, and let's have a look at that in the browser. And what we can see here is that we actually have a proxy. So proxy state tree creates a proxy on the first object. But if I have, for example, bar, which is a nested object, we refresh, we can see that on this proxy, the bar object is not a proxy yet. So it's not like you pass in an object and it makes proxies of everything. It actually does this on the fly. But this like main master tree is not actually what you use. This is just like what should we call it? Like a template for your tree, because there are two different kinds of subtrees. One tree for changing the state of the tree, and one type of tree which is for tracking access to the tree. So typically in an application, you would use a tracking tree inside components to track what they access, so you know when to render. And then you would have the mutation tree, as it's called. You would pass that into actions, where you are supposed to be allowed to change state. Because if I go here and say proxy state tree state.foo equals bar2, say that, we can see that I actually get an error. I'm not allowed to change the state. But if we create a mutation tree here, proxy state tree get mutation tree, and we try to change this instead. Mutation tree dot state dot foo equals bar2. Let's see. Mutation. Oh, sorry. We actually have to start tracking. I'm not sure if this tracking method is really necessary, but currently you have to actually call track. And now there's no error message. And if we take a look at mutation tree.state.foo, you can see that we actually have bar2. But not only that, if we look at the original proxy state tree, it's also bar2, meaning that they actually share the state, the actual state objects, but they have their own proxies, which allow them to do different things with the tree. So let's create another tree here called track state tree. Get track state tree. Yes. And what we want to do here is let's like create a render function. Let's imagine this is something like a component or something. And what we want to do is say track state tree. We want to track, start tracking, and then we want a callback, and that is what do we want to happen when when what you track has a change. And currently we can just console log, see, look at it, and then we of course have to access something that is to be tracked. So let's look at track state tree state.foo. Let's just look at it, and that should be all good. And let's just comment this out for now and call render. Okay. So currently we are, oh yeah, we're logging out this one, don't need that. So currently we are actually, we have created a state tree that allows you to track access, and it's tracked within the scope of this component, meaning that each component gets their own version of the a track state tree, meaning that we have scoped tracking to an instance of a tree inside a component. Which is really nice, because there's no like function scoping or starting and stopping tracking. We're actually giving an instance of something to a component, which it can use to track. Okay, so what we can do now is bring back the mutation. So we are tracking foo. Well, maybe let's see. We can take a look at track state tree path dependencies. So what we can see now is that since we access state foo, the path dependencies of this tree is actually foo. And if I would say track state tree.state.bar, I would access that, we will get that as well. So now it's tracking, and what we can do now is make the mutation run. And okay, sorry about that hiccup. I forgot one important thing about the API. The reason it doesn't update right now is because we don't want components to render on every single mutation. We want to batch up mutations, and this is something overmind handles. But what we have to do is tell the master tree to flush. And what we mean by flush is, okay, if there are any mutations, let anyone, any components that cares about those mutations to render. So if we move back now, we can see that this console log logged out 4 arguments. And the first argument is the mutation we did. So as we can see, we did a set mutation on the path foo on bar 2. So we actually get the path of the thing we are mutating, and what arguments we passed, and the type. And then we also get in a complete list of the paths that were actually affected by this. Because it's not always just a direct path that is affected. Maybe you are adding like a new property to an object. That doesn't mean that only the path to the new property is changed, but also the object itself. So that affects 2 different paths. And then we have something called a flush ID, which is just an ID of the flush. This is used for debugging. And then there's also a boolean for flagging if the flush is asynchronous or not. And this is useful to optimize rendering, because sometimes you do tons of mutations that are asynchronous. So let's see here. What should we do now? This is basically like, this is the core of it. This is what we do. We create track state trees for all the components. They do the tracking, and on their callback they would typically just render themselves again, doing a new tracking and updating the path dependencies, because you might have conditional logic, meaning you track different things depending on each render. And then we have a mutation tree, where typically in development there's multiple mutation trees, 1 mutation tree for each action, and that means you can track, for example here we can do a mutation tree on mutation, console.log I did a mutation, which means we can take a look at whenever we don't even have to flush now, I think. Oh, maybe we did have to flush. Oh, sorry. Of course, we don't have to flush, but we have to listen before we do the change. And that means this information can be passed into the debugger, for example. Or it can help do other things, like asynchronous flushing and stuff like that. Yes, I like this is all there is actually. So like the implementation of how the component gets their tree and starts tracking, it's super simple. And also like how we provide this state to, like for a consumer of the library, it's always just state. You don't care about it. It's just, okay, it's proxies under the hood, but you don't care about it at all. And also in terms of optimization and memory and stuff, like all the track state trees, they are reused. So whenever a component unmounts, we do proxy state tree, dispose tree, and like track state tree. And then that tree can be reused. And also all the proxies are cached, meaning that if you point to a path you have already pointed to in a tree, it will reuse the proxy that is already created for that specific position in the tree. Okay, I don't think there's really much more to say about this. It looks very simple, but it's actually very complicated to implement. And it took quite a few iterations to get to this point, but I'm super happy about where we ended up. So thanks for listening.